Okay, I want to talk about Hamming codes. This is a simple code. I use this simple code to illustrate how channel code works. So in here, there is a cell phone communications scenario. And I want to use a very simple modulation example, which is on and off modulation. Basically, what is happening is here is your cell phone, for example. So here is your phone. Here's your friend. You want to talk to your friend. How the sound wave is reproduced at the friend phone. So you talk to your cell phone. That sound waves is going to be converted into bit stream using analog to digital converter. That bit stream is sent to the cell tower within your cell. So your cell phone is located within the cell, where at the center there is a cell tower. And then you send your bit stream. In this particular case, you have 1, 0, 1, 0, 1, 1, 1, 0, 1. Here I use electromagnetic waves to represent a single bit. So here where I have a box, that means electromagnetic waves are there. And then 0 means no signal sent. And another electromagnetic wave for this time duration, for let's say t second, is t second duration. You send the electromagnetic wave or no wave. This is called on and off modulation. And you send this, and the base station receives your waveform and then do the decoding, ones and zeros. And then it reproduces. So here 1, 0, 1, 0, 1, 1, and so on through the optical cable. And at the receiving cell tower, it regenerates this bit stream, and then in using the antenna, it transmits these information bits. I mean, these bit streams. So 101, 011, and so on. It regenerates and sent to your friend's cell phone, and at your friend's cell phone, these ones and zeros are used to represent voice signal. And this voice signal is reproduced via the speaker at the cell phone. So your friend can listen to your voice. And here, this channel from your phone to your friend phone is going to be statistically modeled this way. Let's say at the input, you have 2 alphabet element, 0 and 1. And at your friend phone, you have 2 alphabet elements, 0 and 1. With the probability P, 0 is flipped to be 1. With the probability P, 1 is flipped, received as 0. And with 1 minus P, no error. With 1 minus P, no error, like that. And then you send your 0 bit with the probability of half, 1 bit with the probability of half, then probability of error, which is probability of error, and at the input you send 0 plus probability of error. Okay, so that's probability of error. If you continue to do that, that is nothing but p times probability of x is equal to 1 cent plus p probability times x is equal to 0 cent. So these two half and half. So this is probability of p. So that's the probability of error. So even in the case that equal the input symbols are not equally likely equiprobable, is not equiprobable, basically the probability of error is key. So this conditional probability defines the channel. And this statistical channel captures all the in-between processings of a bit stream at each wireless channel and also optical channel included. So that's the bit flip errors I wanted to introduce. Let me go to next one. So here is an internet channel. Internet channels is erasure channels. So here is the early internet. The early internet was called ARPANET. And there were 4 nodes, UCLA node, UC, Santa Barbara, I believe, and Stanford, SRI, and Utah, University of Utah, 4 nodes. And Dr. Klein Locke made a successful first login in 1969. And in this network, informations are grouped together. I mean, the information bits are grouped together in the form of a packet. A packet is sent to the computers. So for example, if a Utah node wanted to send a packet to UCLA, it has to go through this route or this route. And whenever a node receives too much information, too many packets, some packets are dropped. And then because of that, erasures occur. So this type of channel is called the erasure channel. And erasure channel, the input alphabet is 2, input alphabet is 0 or 1 cent, and then output alphabet 0, 1, or erasure. So it has this type of relation. And when 0 is sent with the probability of 1 minus p, 0 is received with the probability of p, erasure occur. With a bit 1 cent, with the probability of p, erasure occur. With the probability 1 minus p, 1 is received. So this is called erasure channel.